Hello, ladies and gentlemen. Welcome back to Math 30-1, Chapter 2, Section 2, Graphing Rational Functions. Now we're moving on to the first part of the main handout. Note, it's a set of notes. You don't have to hand in. These are notes. Don't hand them in. They're for you to keep and to read through. So, as we go along, remember, if I go too fast, hit pause. Now, the instructions are graph each function. Use the table feature to check for any non-permissible values of x and to examine the behavior of the graph when the absolute value of x is large. That is, when x, positive x, goes towards infinity, or negative x goes towards infinity. Take a quick look at your table, scroll up and scroll down, see what it looks like. Now, let's get started. The function y equals x squared minus 1 over x plus 1. Here, I want you to graph this, but first, I want you to see if you can factor or simplify. Now, I will give you one hint. Whenever you see minus 1, realize that's the same as minus 1 squared. And when you do that, you have a difference of squares. And the numerator is x plus 1, x minus 1, and the denominator is still x plus 1. What's common to both? X plus 1. So this simplifies to x minus 1. So my factored form is x minus 1. Sorry. I should technically be saying y equals x minus 1. Now, before you go any further, note we canceled something out. X plus 1. Our original equation had x plus 1 as the denominator. So if we go x plus 1 cannot equal 0, subtract 1 from both sides, x cannot equal minus 1. So I have to make a note of that at the end, x cannot equal minus 1. So otherwise these two equations aren't equal. X cannot equal minus 1. Now, grab your graphing calculator and graph it. You should see, looks something like this. That's y, that's x. Grab your graphing calculator. It looks something like this. Minus 1 goes up. And you'll notice I'm putting a hole at x equals minus 1. Why am I doing that? Well, look at your graph. Depending on your windows, you may or may not see the gap. But go to your table of values now. Go to your table of values. I'm going to pause it. I want you to pause it until you find the table of values where you find x equals minus 1. Okay, now that you found x equals minus 1, your table of values here shows that there's an error. Here is minus 1. So it goes x is 0, y is minus 1, x is minus 1, y is an error. There's a hole, or the technical term is discontinuality. At minus 1 comma minus 2. This line does not exist. That's important to note. Now, if you have trouble, pause, go back and reread this. You have a gap. It's probably not showing up in your TI calculator. Check your table of values. That's why we went and found our original denominator. Now, pause the tape recording, double check that. When you're ready, come back and we'll do the rest of this. Okay, going on, my x-intercepts from my graph, plus 1. Sorry, I should say x equals. Now my y-intercept, y equals minus 1. Non-permissible values of x, but x doesn't work. X cannot equal minus 1. Now, asymptote. An asymptote is a line the graph approaches but doesn't cross. We have no vertical asymptote here, we have no horizontal asymptote. Calculus class, we can argue about asymptotes here, but not now. This is merely a hole or discontinuality. Okay, when you're ready, go on. We're going on to the next equation. So, once again, I want you to factor this. Pause the recording for a moment, factor it, then come back and check to see what I've done, and we'll take it from there. So please pause now and factor. Okay, now that you're back, the numerator, two numbers that multiply together to be minus 2 and add together to be plus 1 would be x plus 2 times x minus 1 for x plus 2. And note, x plus 2 is in our denominator. X cannot equal what? The equation simplifies, to x minus 1. However, something cancels out. And checking that out, x plus 2 cannot equal 0. Minus 2 from both sides, x cannot equal minus 2. So, factored form this equation, y equals x minus 1, x cannot equal minus 2. And I'm going to skip right ahead to my non-permissible values of x. We just said it, x cannot equal minus 2. Now, I want you to pause this recording, and I want you to graph this equation, please. Okay, so you're back, so I'm assuming you've graphed it. The equation looks something like, the graph looks something like this. Note I'm getting lazy and not always labeling my x and y axes. If you don't know which is which by now, you have a problem. So here it is. We get x equals minus 2. All of a sudden, it doesn't exist. We have another hole of discontinuality. Once again, x cannot equal minus 2, so check your table of values. You should see a discontinuality or an error. Now, the rest of the questions are quite straightforward. X-intercept, x equals plus 1. Y-intercept, y equals minus 1. There are no vertical asymptotes, no horizontal asymptotes. We merely have a hole at minus 3, minus 2. Oh, sorry, not minus. Minus 2 is my x value, and we write x first. My apologies, ladies and gentlemen. So it's always x, then y. Okay, so far so good. Whenever I give you one of these graphs, or one of these equations, I want you to try factoring it. Now, third one, x squared over x minus 1. We try factoring it. Factors of x squared are x times x over x minus 1. Nope, we can't cancel any of that. Now, so all we can say is y equals x squared over x minus 1. Now, here we really do need Mr. Graphing Calculator to do this. So I want you to pause the recording, and I want you to get Graphing Calculator and graph this for me now, please. Come back when you're done. Welcome back. By now, I'm assuming you've graphed it on the calculator. So you're going to go something like this. Now, it's a rather crude attempt. Let me please go something like that. Not the best drawing, but you get the idea. Now, from the graph, you can read off the x-intercepts, but I want to point out, well, a couple of things first. First, we have a vertical asymptote. Right here at x equals plus 1. So going down to part E, vertical asymptotes, x equals plus 1. Now how do I know that? Well, I can read it off my graph, but more importantly, go back to my original equation. What's the denominator? X minus 1, it can't equal 0. So there is my asymptote, x. Now, that's an important thing to know. I will give you the equation, you'll have to come up with the asymptote. Now, another color I haven't used. Let's pick blue. The x-intercept, y equals x squared over x minus 1. The x-intercept, y equals 0. So this is 0 is equal to x squared over x minus 1. Now, here, basic math, how do you get rid of divide by x minus 1? We multiply both sides by x minus 1. And this is something I expect you to be able to do. If I give you the equation, as for the x-intercept, you will solve it and get the and find the final equation. 0 is equal to x squared, or x equals 0. Now, I expect you to be able to solve that algebraically, because you're going to get the odd question where it's x squared over x minus a. You can't graph it. You have to understand the theory behind it. Now, look at that for a sec. Here we have to go on and find the y-intercept. Well, the y-intercept, x equals 0, so y equals x squared over x minus 1, or 0 over 0 minus 1, which is 0 minus 1, which is 0. 0 comma 0. Other questions? Non-permissible values of x. Oh, the asymptote. X cannot equal plus 1. Horizontal asymptote. There's no one line that graph approaches. So there's no horizontal asymptote there. Okay. If you're having trouble, pause the tape recording and review this, and then go on to the last question for this part. And here we are. Last question. X squared plus 2x plus 1 over x plus 2. First things first, can we factor it? Well, if you do a little bit of grade 10, that's x plus 1 times x plus 1. Two numbers that multiply together to be 1, and add together to be 2 would be 1 times 1. And darn it, nothing cancels out. I was hoping something would. Note, if something cancels out, you get a hole or an asymptote. You get a hole or discontinuality. So the factored form of this is y equals x plus 1 squared for x plus 2. Now, pause the recording, graph this please. Come back when you've got it graphed, and we'll talk some more. Okay, welcome back. So your graph should look something like this. Not the best. However, I do want you to note, now, TI series may or may not draw the asymptote in. It's not supposed to, but sometimes it does, just to confuse you. Now, from this graph, can you find your x-intercepts? Sorry? And your y-intercept. Now, notice I say intercepts, you can have more than one. X-intercept, y equals 0, so this is 0 equals x plus 1 squared over x plus 2. Now, when I ask for the x-intercept, realize that we're always getting rid of the denominator. So if you're lazy, you can just cancel out the denominator. Though I would prefer if you showed work. Actually, I insist you show work. So 0 is equal to x plus 1 squared, the numerator. How do you get rid of the square? Square root both sides, of course. So we're down to 0 is equal to x plus 1. Subtract 1 from both sides. X equals minus 1, which you can see off our graph. Now, the y-intercept, you find it in a similar way. Here, x equals 0, you're crossing the x-axis. So this is y equals 0 plus 1 squared over 0 plus 2, which is 1 squared over 2, which is 1/2, or 0.5. It's right there in the graph. From here on in, everything else is straightforward. Take a quick look. Non-permissible values of x. X cannot equal minus 2. The vertical asymptote x equals 2. And there's no horizontal asymptote on the line that approaches and doesn't cross. That's it for part 2. Review this. When you're ready, we'll go on to part 3. Thank you.